Alright, so let's go ahead and get started. So next we're going to move into graphing tangent and cotangent functions. So, oh, there you go. It says use the unit circle to complete the table of values. So our tangent is our y value divided by our x value on here, okay? So then if we are looking at this first one, we have 0. So at 0 degrees, we're going to take our y value, which is 0, and divide it by our x value, which is 1. So we do 0 divided by 1, and 0 divided by 1 gives us 0. Okay. Then we go to pi over 4. So I look up pi over 4. Pi over 4 is right here. I'm going to take my y value, which is the square root of 2 over 2, and I divide it by my x value, which is also the square root of 2 over 2. And so when you divide something by the same thing, like 1 divided by 1, 2 divided by 2, 3 divided by 3, it's going to give you 1. Okay. Then we're moving on to the next one at pi over 2. So here's pi over 2. We're going to take our y value, which is 1, and divide it by our x value, which is 0. And this time, 1 divided by 0, that does not give you 0, it gives you undefined. Then we move on to the next one. We have 3 pi over 4. So then 3 pi over 4 is right here. So I'm going to take my y value, which is the square root of 2 over 2, and I'm going to divide it by my x value, which is the negative square root of 2 over 2. And so that gives me negative 1. Then we have the next one, which is pi. So then here at pi, we're going to take our y value, which is 0, and divide it by our x value, which is negative 1. And that gives you 0. Then we move on to the next one. My y value here is the negative square root of 2 over 2. And we divide it by the negative square root of 2 over 2. So the negative square root of 2 over 2 divided by the negative square root of 2 over 2. That gives me 2 negatives, make a positive, so it gives me positive 1. So moving on to the next one here at 3 pi over 2. So at 3 pi over 2, I'm going to take my y value and divide it by my x value. So negative 1 divided by 0 gives me undefined. And then next we have 7 pi over 4. So at 7 pi over 4, we're going to take our y value, and then we're going to divide it by our x value. So here we have the negative square root of 2 over 2. Divided by the square root of 2 over 2. And so it's going to end up giving me a negative 1, because a negative and a positive gives me a negative. And then last, we go all the way back around to 2 pi, which is back here. We're going to take our x value, which is 0, and divide it by our y value, which is 1, and that's going to give me 0. So I'm going to go ahead and graph these points. So at 0, I have 0. So 0, 0. At pi over 4, I have 1. So this is pi over 4, it is 1. At pi over 2, it is undefined. So when we have it undefined, we actually have an asymptote. I look at the next one. The next one is going to be 3 pi over 4 is negative 1. So this is 3 pi over 4 is that negative 1. At pi is 0. At 5 pi over 4, it is 1. And at 3 pi over 2, it is undefined. So I'm going to make another asymptote here, 3 pi over 2. Okay. The next one, 7 pi over 4, it's negative 1. So negative 1. And then here at 2 pi, it is 0. All right, so then from there, if I look at this, there's a little pattern that we see going on. For a tangent, it's going to look something like this. I'm just going to do it on this one first. And so this one's going to be the exact same thing. Okay, we're missing this side of the graph. So this side of the graph, I'm missing this little dot. So we'll make our 3 little dots, and then right next to it, we're going to have an asymptote here. Okay. And then our graph looks like this. I'm going to follow that same little pattern and make those 3 little dots, one at +1, one at 0, one at -1. And then right next to it is our asymptote. And then the same thing for the last section, except we don't have enough space for the other one. Okay, and then it just keeps following the same pattern over and over and over again. So here, these are the characteristics of tangent. So here they want to know what the period is. And so they tell us that the period here is always going to be pi over the absolute value of b. For secant and cosecant, it's 2 pi over b. But this one, because it's tangent, is only pi over b. And so the b is the number being multiplied with the x. So this would be our b here. It would be 1. Okay. So if we do pi divided by 1, that gives me pi. So my period here is pi. So what that means is that for it to complete one full cycle, it only takes 1 pi. So if you notice from here to here, it does like the little, it kind of looks like the cubic function. And then it starts all over again. And then it starts all over again. And I know it's pi units because each little square is a quarter pi. So it takes 4 little squares to complete that little cycle before it repeats again and again and again. So that's what the period means. Then we have the amplitude. So for amplitude, it's going to be none. Okay, we only have amplitudes for secant, sine and cosine. Because we have like little waves. That's what the amplitude is. Okay, it's how high the waves are. This one we don't have little waves. Domain. The domain is going to be all our x values that are covered here. Okay, so our x values are going to be all real numbers except for wherever we have an asymptote. So we have asymptotes at -3 pi over 2. So x cannot equal -3 pi over 2. It cannot equal -pi over 2. It cannot equal pi over 2. And it also cannot equal 3 pi over 2. And then, of course, our graph keeps going and going and going. We just happen to stop there. So when you write this down, we don't write it down with those numbers. We are going to make a generalization. 1, 2, 3. And so we find the pattern is what we're going to do. So all of these are all divided by 2. Okay. If you notice, all of them are divided by 2. All of them have a pi, 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 and pi. So all of them might have a pi on top. The part that changes is the number in the front. So this is -3. This is -1. This number here in front is 1. This number here is 3. So if we continue that pattern, it seems like all of these are odd numbers, right? So the way you write an odd number would be 2n plus 1. Okay. And n can be any number, but it has to be a whole number. So that's why we're using n. So if you put, for example, 1, 2 times 1 is 2 plus 1 is 3. Or say n is 0, 2 times 0 is 0 plus 1 is 1. Or say n is -1. -1 times 2 is -2 plus 1 gives us this -1. So this is the answer that you guys are going to see on your delta math. You're not going to see these ones, you're going to see this one. Because the 2n plus 1 produces an odd number. The range, so our range is how low our graph goes and how high it goes. So if you notice, our graph points down forever and then it continues on up forever. Okay, there's no gaps in our y values. So for our range, it's going to be all real numbers. Okay, and that'll be for all of our tangent and cotangent function. It'll always, always, always be all real numbers. And then our asymptotes. Well, our asymptotes are right here where our domain says we can't equal these numbers. We can't equal those numbers because there's asymptotes there. So then whatever we get from here, we have to write it here, but it's not x does not equal. We're saying x equals, and we said it was 2n plus 1 pi over 2. All right. Now let's look at cotangent. So cotangent, use the unit circle to complete the table of values. This time our cotangent of theta is our x value divided by our y value. Okay, so it's backwards. So here at 0, we're going to go ahead and take 0. We're going to take our x value, which is 1, and divide it by our y value, which is 0. So this one gives me undefined. And then we look at the next one. This one is pi over 4. So at pi over 4, it's the square root of 2 over 2 divided by the square root of 2 over 2. So when you take the square root of 2 over 2 divided by the square root of 2 over 2, that gives us 1. Then we move on to the next one. At pi over 2, my x value is 0, my y value is 1. Remember, we're doing x divided by y. So 0 divided by 1 gives us 0. Then we move on to the next one. We're going to look at 3 pi over 4. So here's 3 pi over 4. It is a negative square root of 2 over 2 divided by the square root of 2 over 2. Remember, we're taking our x value and dividing it by our y value. That gives me negative 1. And then next, we're going to take our x value, which is negative 1, and divide it by my y value at pi. So negative 1 divided by 0 gives me undefined. So wherever we have these undefined, that's where we have asymptotes. Okay. The next one at 5 pi over 4. So here's 5 pi over 4. We have the negative square root of 2 over 2 divided by the negative square root of 2 over 2. And so that's going to give me negative 1. And then next, we have 3 pi over 2. We're going to take our x value, which is 0, and divide it by our y value, which is negative 1. So 0 divided by negative 1 gives me 0. The next one's at 7 pi over 4. So here's 7 pi over 4. We're going to take our x value, which is the square root of 2 over 2, and we divide it by our y value, which is a negative square root of 2 over 2. And that gives me a, is it a positive or a negative 1? It's a negative 1. You know what? This one should have been positive. Because both of them were negative, and 2 negatives make a positive. All right, and then last at 2 pi. At 2 pi, 1 divided by 0 gives me undefined. All right, so we're going to go ahead and graph that here. Remember, everywhere where we see undefined, we're going to put an asymptote. So we're going to have 3 asymptotes here. 1 at 0, 1 at pi, and 1 at 2 pi. So 1 at 0, 1 at pi, 1 at 2 pi. So if I continue that pattern, I'm going to have another asymptote here at negative pi and negative 2 pi. Okay, then I'm going to go ahead and graph this. We have 1, 0, and negative 1. So at pi over 4, it's 1. At pi over 2, it's 0. And 3 pi over 4, it's negative 1. For the next one, at 5 pi over 4, it is 1. At 3 pi over 2, it is 0. And at 7 pi over 4, it is 0. So if I continue that same pattern here, it'll be 1, 0, negative 1. 1, 0, negative 1. All right, so here if you guys notice, the tangent and the cotangent functions I'm trying to scroll down, but it doesn't let me. They kind of look exactly alike. The only thing is that our tangent function, our little graphs are going up, and our cotangent, our little functions are going down. Okay. One other thing, our asymptotes are different. Here our asymptotes are at the halves. Here our asymptotes are at the whole numbers. Okay. So for a period, we take pi and divide it by b. B is a number that is in front of this x. This is our b. In this case, our b is going to be 1. So pi divided by 1 is just pi. Then amplitude, remember there's amplitudes only on sine and cosine, not anything else. Okay, so it's none. So main is going to be all the numbers except for where we have asymptotes. So x cannot equal where we have asymptotes. So x cannot equal negative 2 pi. It cannot equal negative pi. Cannot equal 0. And it cannot equal pi or positive 2 pi. Okay. But we can leave it like that because the graph is going on forever and ever and ever. We can't write numbers on forever. So we generalize it. Now, we see what they have in common. They all have a pi in common, except for the 0, but 0 times pi is just pi. Okay, and then these numbers are not even numbers, they're not odd numbers, they're both. So it's just going to be n pi. Okay, any whole number times pi. Negative 2 is a whole number, negative 1, 0, 1, 2 pi. So this is what you're going to see. Okay. So our domain, our x cannot equal these numbers. Why? Because we have asymptotes there. So x is equal to n pi. That's where our asymptotes are at. And then our range is how low our graph goes and how high it goes. So it goes down forever. There's no gaps in our graph, and it goes up forever. There's also no gap. So it's all real numbers.